Okay, thank you very much. So I'm Steve Boyer, and I work at the IBM Almaden Research Center, which is shown here. It's a new picture, actually, from taken by Jeff Krulin. And that's where we work, and I'll just review quickly what we do and where we're going. So primarily, the team that I work with is focused on what we call computer curations. We started with the computer curations of patents, and we also do Medline and other types of scientific literature. Patents, as you know, and journal articles or what have you, in-house documents contain chemical content, both as text, as image, and as what we call complex work units or manually curated data. And what we try to do is basically build a back-end environment, which we've been working on at Almaden for some time. And this back-end environment enables us to take in various data collections. We integrate it into our computing environment, and from there we annotate the data. We do annotation of text, so we try to identify the chemical names and convert them to structures. We also analyze the images, and we also provide some analytics on top. And we do integration with other types of databases like Chembol and PubChem and Orange Book and things of that type. We also we also have been focusing more recently on building analytic tools for the front end, so that where we're really going is not so much in the data curation, but we're moving or migrating from the data curation aspects into the analytics. Once you get the data, as you know, it's no matter what type of technology you use, it's often very dirty. Just by the nature of the data itself, you get these patents, and they use very vague terminology, misspelled terminology. It often leads to erroneous structures. So for the last 6 months or so, with the help of our collaborators, many of whom are here, we've been focused on developing various cleanup operations. And here we use a lot of ChemAxon tools and the ChemAxon libraries to post-process and clean up the data. And so that's been a major effort in the last, I'd say, 6 months or so. And once we have that data, what we do is we have a family of companies with whom we collaborate with on this project. They have a copy of our database inside their firewall. We do the annotations on a regular basis, and then we replicate the data out to our collaborators' environment. And I should say, I guess everybody uses the Oracle database with cartridge, but in-house we run DB2 very effectively with the ChemAxon search engines and tools. So we made a more or less unanimous decision to standardize all the cleanup operations on using ChemAxon libraries, and the data tables in these databases are all being updated with the post-process data. Once the data is in the customer's environment, what we've been working on now is providing some web-based tools to enable the analytic, shall we say, analysis or use of the data. And I'll just say we can do things like charting and comparative analysis. These are some screenshots of our Simple application. Simple was the research name for it. It's now being transitioned to IBM Global Services, and it'll be called SIP, which stands for Strategic Information IP Platform or something. In any case, all the data is indexed with the Lucene. We use Solar on top of Lucene, so you can do full text searching. You can do structure, substructure searching using the ChemAxon tools. And you get a hit list. You get basically, we can tell whether the molecules occurred in a patent, where in the patent it occurred, and what have you. Over here, we have some new tools that we've just developed, which will enable us to do cluster the patents by families. We can do things like snippet analysis, so we can look for the term that you searched for and the contextual environment of that term. We do nearest neighbor analysis. We do something called proximal search, so that instead of using keyword searching, you can put in a document or a paragraph and use that as the query. So we have a number of nice analytic tools that we continue to develop. Here we show molecular timelines. It shows where the molecule occurred in this particular document and where it occurred in its history. I call this a molecular timeline, how many times it occurred in different documents, the first term occurrence. We do trend analysis and things of that type. Some more visualization tools. These are all built into the web application, simple. We also have something new called patent quality analysis. We do things like Rule 112 analysis. We can find problems in the patent applications. We also do bulk searching. So if you're filing a patent and you have, say, 300 compounds, you want to search them all at once, you can do that. So in summary, that's where we are at. Where are we going? So more and more, you may have heard that this past year, IBM had something called Jeopardy on TV, where in the past we did Big Blue, the Blue Gene won the chess tournament, and then more recently we did Jeopardy with the Watson computer. And what we're trying to do now, we have a project that we're just now initiating called Deep QA, where we're going to basically exploit the Watson technology. And instead of, say, winning game shows, you'd be able to do hypothesis querying and try to apply this to things like medical diagnostics. And in order to do that, what we have to do is build the knowledge base. And so our team is providing one little input into a sliver of this. So if you want to find out more information, contact me. But this is where we're basically headed with the Watson Deep QA project. And there's some of the contributors. So thank you very much.